Assalamu alaikum, ladies and gentlemen. My name is Abdullah Altaf. My roll number is U level 3 level 58, and I'm a student of computer sciences fifth semester. So today I'll be presenting my design and analysis of algorithm semester project on Prim's algorithm for minimum spanning tree, including its design, analysis, and visualization. So in Prim's algorithm, for every algorithm, first of all, we have a problem and then we find a solution for algorithm. So what's an algorithm and what's Prim's algorithm? So before defining that, we should know what's the problem. Why do we need Prim's algorithm? So the problem is to find the minimum spanning tree, which we call the MST of a connected, weighted, and undirected graph. The MST connects all vertices with minimum total edge cost and without forming cycles. So there are inputs, vertices, weighted edges, output, MST edges, minimum cost. So for this problem, why do we need MST, minimum spanning trees, and why do we need Prim's algorithm? What's Prim algorithm? So minimum spanning trees are used in real life applications like network design, routing, and clustering. So I selected Prim's algorithm because it is a greedy algorithm and it works efficiently for the dense graphs and whatever we call it. So Prim's algorithm, let me define the algorithm without the code, definitely without the code. So Prim's algorithm. Prim's algorithm starts from a single vertex. There is one vertex, and each vertex, it selects the minimum weight edge that connects visited vertex to an unvisited vertex. So we have two vertices, we have this edge and we have this edge. So it selects, for example, this edge has the minimum weight. So it selects this one from this one and it moves to this. That's how it works. And this process continues until all the vertices are included in the MST like this. All the vertices are included. I'm going to show you as well. But before that, I'm going to be reading some slides. And so basically, my partner Ramin is also in the group. She's not in the video, definitely. Dr. Mohammad Sanaullah will be evaluating my course. So basically, what's the problem statement? So we have to find the minimum spanning tree of connected weighted graph, and we have a goal to minimize total edge weight while connecting all vertices. So why the minimum spanning tree? It's used in network design, as I told you, routing protocols, clustering, optimization problems. So basically, this is how the it works, and there is this Prim's algorithm. I'll be defining this one. So Prim's algorithm is a greedy algorithm. It builds the MST by selecting the minimum weight edge, connecting visited and unvisited vertices. So I was telling you about the pseudo code starts from any vertex and it repeats until all vertices are visited. But remember, it always selects the edge or the node with the lowest cost. Select the minimum weighted edge, the minimum weighted cost, and add edge to the MST. So the correctness and complexity of the algorithm. The correctness of Prim's algorithm is definitely based upon greedy choice property and cut the property of MST, each selected whatever the you can call it edge is safe and leads to an optimal solution. So it's based on greedy choice property and it uses it's written uses cut property of MST minimum search tree. It always selects a safest edge, which is the optimal MST. So the implementation overview. So I have done it two ways for the implementation. The first way was Python visualization. So it's I've used NetworkX Matplotlib library for the visualization, which I will be showing in the next slide. And I've also used HTML, CSS, and JavaScript for interactive user interface. So Python visualization goes something like this for NetworkX and Matplotlib. Step-by-step MST information, edges highlighted dynamically used for algorithm correctness. So it moves from 0 to 2 because the lowest cost is 2, then 2 to 1, 1 to 3, 3 to 4, and 4 to 5. Definitely 4 to 5. There are two axes, x-axis and y-axis. I'll be moving forward to the next HTML, CSS, and JavaScript visualization, the web-based visualization, which we call it. I'll be demonstrating the web-based visualization of Prim algorithm. So each step I'll be showing you in the web as well. When we click the next step, interactive canvas, colorful nodes and edges, button-based step execution. The MST total cost is 14. It moves from 0 to 2, 2 to 1, 1 to 3, 3 to 4, and 4 to 5. So basically, there are green nodes, blue nodes, and red nodes, the MST edges. The implementation uses JavaScript. Yeah, that's important one. The implementation uses JavaScript to replicate the algorithm logic, while HTML canvas is used for the visualization. So I'll be showing you the Python code as well now. Well, as you can see, there is this Python code where I have used the matplot library as well as import network X, import time, and this is how it looked like. I'll also be running it as well. So we have the edges 014, 023, and whatever right here. We have the edges here. We have defined raw graph function and selective edges, and we have called plt.clf here. And this right here draws the node color. This line right here draws the node color to light blue, and weight defines weight. And basically, there's the Prim algorithm. I've defined Prim here to start. This right here starts a Prim algorithm. This sets the visited nodes, the MST edges, into an empty array, while the len visited is less than len g nodes. Minimum edge is none. Minimum weight is definitely the float data type into INF. So there is the for loop used in for u in visited for v in g neighbors. So it keeps visiting the next node one by one. So and there it returns the MST edges. So to run it, I'll just be writing some Python prim underscore visual.py. I'll be just running it. So as you can see on the screen, it's basically loading. And after loading, it will be showing you how it basically runs all the nodes one by one. And like it goes from 0 to 2, 2 to 1, 1 to 3, 4, 5, and so on. It keeps working. So this right here is the code, and it's basically loading. This loop makes sure that all the nodes and edges are visited one by one, and this weight right here written makes sure that the lowest weight edge is visited. So the cost is lowest, as the cost was 14 in my case. So and I'll also be showing you the web-based version as well now. But before showing you the web-based version, I'll be showing you Python prim underscore visual, just for the basic understanding that how it works. And now it is basically loading. So as I showed in my presentation slides, that here we go. So here it is. So it's running from 0 to 1 to 3, and then to 2, and cost 2 to 4, and 4 to 5 because the cost was 6. And you can see the x-axis and the y-axis as well in it. So this is how it works. And now I have to show you the web version as well. The web version, the basic HTML, CSS, and JavaScript version. So it's like this right here. Here, the screen changes. You can see the doc type HTML. HTML head is the code. And basically, I have to show you the main JavaScript code right here. It's over here. All right, we're into the JavaScript page. It's loading. So maximum search tree, push min edge. Here, the constant edges and the constant nodes are defined with their axes of x-axis and y-axis, and the constant edges are u, v, and w with weights, cost, and their lengths. So now, as we zooming to the web version, I can show you here's the button that takes us to the next step. So it goes to 0 to 2 with the cost of 3. As you compare the cost, here the cost was 3 and here the cost was 4. So it goes from 0 to 2, and then I click next step. Then it goes to 2 to 1 because here the cost is 1 and here the cost is 4. It could have moved from 2 to 1 except 2 to 4, but it moved to 1 because the cost was 1 there. So now it has the option to go to 0 or 3. The cost towards 3 is less than the cost towards 0. So it moves towards 3. Similarly, it moves toward 4. And finally, it moves toward 5. So now, to the visualization, we can see that all the nodes have been completed. So finally, we click the next step and it showed the MST completed and the total cost here was 14. So the results and basically let me show you the code as well. So JavaScript code. Basically, both implementations generate the same MST and total cost. The Python version focuses on algorithm correctness, while the web-based version enhances visualization and interaction. So let's just conclude this because we don't have time. In conclusion, this project demonstrates the correct implementation and visualization of Prim's algorithm. Visualization significantly improves maybe understanding of greedy algorithms. Future improvements may include priority queues and comparisons with Kruskal's algorithm. So that's it. That's it for my presentation. That's it for my slides as well. So let me know, guys, if you have any type of questions, you can let me know in the comments. I'll see you guys in the next video. Till then, इजाजत दीजिए. Bye.